Okay, in part 2 of the second assignment, now we're going to make histograms for both of these data sets. All right, to make a histogram, what do we need? We need a set of bins. The bins are the smaller little stepwise ranges of measurement values that we're going to count up the number of the frequency of times where we had data values up here in our data set that fall into the region of a bin from its low value to its top value. You'll see how this works out. But now we're going to go with our bins. We have to go up. It's best to go a little above the maximum value of any number here. And so we really look at the min and the max to see what the range of numbers we're going to span with our bins. And so the max is 15. So I would want to go to a bin at the top here of greater than 15. And it might be 16. Actually, let's do that. Let's go from 0 to 16. Generally, you just want a number of bins, like depending on how many data points you have. You want maybe 10 bins. You could have as few as 5 or 3 at the minimum, probably, but you could have 10 bins. You could have 20 bins. Somewhere in that range is most common. So let's go up in steps of 1 here, from 0 to 16. And I have a way of doing this. I make this a formula and I go equals whatever this number is plus 1. So that 0 plus 1 is 1. And then I Control C, copy that, and I paste that into these cells below it. Select the cells where I want to paste that, Control V. And by doing that, each formula goes to the number above it and adds 1 to it. Okay, so at 13, we go to the place where 12 is, and we add 1 to it, and that goes up to 13. Okay, so we've gone a little beyond here. We'll stop here. So those are the bins into which we're going to count and put the frequency then for problem 13 data. Frequency problem 13 data set. Okay, now I'm going to make this a little wider. You can see how that's not readable to the left here because there's something here, but it does bleed over to the right. If I type something here, you can't read what I wrote here. So one way to handle that is go up here to Format, Text Wrapping, and wrap that. And that widens this row, and then it wraps that data so that we can read what's in this, what's called the header for this column of data. All right. Now, there are no values less than 0. I know the frequency here is going to be 0, but there might be. Here's one that's less than 1. That's the only value I see right offhand. So we're going to expect a 1 here. Whoops, sorry. I jumped over with my arrows. But there's a way to fill in this whole frequency table for this distribution with a formula. And so this formula, I think this works in Excel as well, is frequency. Q-U-E-N-C-Y. And begin a parenthesis. And now notice it wants 2 things. It wants the data set that we are going to distribute and find the frequency of in the bins. So I go up with my mouse, I left click, and I hold my left button down and scroll over here just like we did for the formula. Now, notice it said data and then comma. So I'm adding a comma. By adding that comma, it's now telling me it's ready for classes. Classes is another word for bins. the array or range containing the set of classes. So it wants to know where are the bins that the data is going to get divided into. So I'm giving it now the bin list. I'm using my scroll button on my mouse. Okay, so enter that data set. And notice when I hit enter right here for this formula, right here, the formula's only place it is here. But it now goes up and it counts from this data set. How many numbers fall between 1 and 2? There's 1 up here. One number between 1 and 2. It's got to be 1 point something. I don't see it offhand. Maybe you do. The way these go is greater than 0 up to and including 1, I think. But we'd have to read the manual for that. Anyway, there's 1 between. There should be 3 numbers here that are greater than 2 and up to and equal to 3. And so there's one of them. There's the one that was greater than 1. Oops. Greater than 1 up to and including 2. So 1.5 is this one right here. Now these 3 numbers are this one, greater than 2, less than or equal to 3. So 1, 2, 3. That one. Okay. If I hold the control key down, I can select all 3 of those. Okay. Each one of those numbers is greater than 2 and up to or equal to 3. If there was a 3 here, it would have been counted, I think. And let's just test that. Let's just type a 3 in here and see if that changes this. No. But if I type a 4 in here, watch this number here. See? It comes out of that class and goes up here. So once again, Control Z goes back to where I was. So you see what this formula frequency is doing, right? And now we have a frequency table, and if we left click up here and include these headers, and hold the left button down on the mouse and drag down here to the cell at the bottom right, we've selected the data we want to plot. Notice I did not include this this row here where there's no number for the bin. That's important. Okay, then I want to go up here and select a chart and insert it. I can either go click on that little icon or insert up here, insert chart. Okay, click on that. Okay, now there's some things that if we know what we're doing, it's very good to do them. One is it's asking us, do we want to use row 16 as the headers? Row 16, and the headers means use these words here as labels for our data sets. And it's trying to plot 2 data sets here, bins and the frequencies. But there's something really strange about this. This doesn't look at all like I want it to. This is a number 11 items here. Now, I don't see why that's appropriate at all, except there's 11, there's 3, there's 11 items up to 3. I don't understand this at all. But here's the weird thing here. Now, column D, if we use column D as labels, that means they go on the x-axis. Labels on the x-axis, because the headers are the labels in the legend. And we'd call each of these a series. Now, I know this is getting a little long-winded, But yes, we do want column D to be labels on the x-axis. And really, in many cases, we want this first column to be x values on the x-axis, especially when we get into plotting lines, or what we call an XY scatter plot. So in most examples here, we're going to want to use column D, the first column, as labels on the x-axis. Now, this is simply a chart here. Actually, no, they're showing us a histogram. I really want a column chart. When you use histogram here, it's actually trying to do all the calculations that we did with that frequency formula. I'm going to have to look at this and figure out later what's happening here. I think I see, but it's counting up numbers and inventing bins here. That's not what we want. And so I'm selecting a column type chart instead of the histogram chart type. So notice now this is looking better because I've got 16 bins here from 0 to 16. And the biggest numbers here, like here bin 11 has problem 13 data set a 9. So bin 11 has 9 numbers in it. So see, this is looking a frequency of 9 here for bin 11. That's looking the way I want it to look. So we're not using a histogram chart here. We're just using a column chart to plot our histogram for the data set in problem 13. You get a greater selection of charts here. Notice we've picked column chart, this type. And if we had more than one set of data, which we will, we'd have some red columns in here too. But this is perfectly okay for a chart. While we're here, we can go in and put a chart title here. Let's call this histogram problem 13 data set. Okay, and since now we are deciding to use a column chart to do our histogram, it doesn't know what to label the axes at all. I'm going to hit enter there. Notice that puts a title up there. And then coming down, the legend looks okay to me. I scroll down here. The horizontal axis now, I want to have a title on that. This is bins. And what actually are we looking at now? We're looking at enzyme activity. All right, those are the measurements, micrograms per milligram or something like that. But we've put those measurement activity values into little ranges, and so we call them bins. And so that's okay for that. And then horizontal axis. And now if I click here, I get to do the left vertical axis. And always the title of a histogram's vertical axis is frequency or count. How many are in each bin? So then we'll hit OK. We can come back to edit it later, but there's a frequency histogram for problem set, data set 13 and problem 13. So we finished problem 13. We do the same thing for problem 14. Only here, the maximum value is 3. So maybe we want to go in half steps. So let's do that. Let's make our bins for problem set 14 here. We start at 0. And let's say this next bin is going to be 0 plus 0.5. Enter. And then I want to click here and copy this and select down here and paste. And so that goes up to 5, and that's going to do more than I need. So let's just go up to 5 here is our maximum bin. How did we do that? Frequency for problem. Notice if I hit enter to think I was going down like a hard return, it would throw me out of this cell into the next cell. So you just have to let it wrap itself, text wrapping later. Okay, so now we're going to do frequency again. Equals frequency, left parenthesis, give it the data. We only need that. And then add a comma. It's ready for the classes. Give it just the numbers in the bins. Hit enter, and it fills in these frequencies for each bin. There are 4 numbers in this data set that are greater than 0 and less than or equal to 0.5. Nobody actually equal to 0.5. Notice there's one number that's actually equal to 0, that guy right there. So this bins go from whatever's below it to up to and including whatever's written here. That will count as a number that we count for the frequency of numbers that fall into these bins. Okay, so let's go ahead and plot that again. We select that data, we go insert, chart, and we're going to use column G as labels. Notice it's given us a horizontal column column chart. That's just very similar to this. It just turned on its side. There's nothing wrong with it, but we want this kind of chart, okay? And once again, you go to Customize and find where the chart title is. Histogram problem 14 data set. Okay. Label the axes again. Horizontal axis title is bins enzyme activity. I think micrograms per milligram of protein is usually what that is. And then vertical axis, once again, is always frequency or count. One or the other, or both. All right, I think that's good. We hit insert, and we throw in, we're done with problem 14. And I think that's a good place to stop right now. But actually, let's not stop there. Let's just ask you one more thing. They want in these problems answer the question, do you think these cells have taken up the gene fragment containing the enzyme based on these data? Explain. So when you look at this histogram here, what does it tell you? And now, notice they did problem 13. This is really going to be a good starting place for our quality control discussion. They first did this assay with all the clones that had been treated with DNA. And then they realized their mistake, and they went and they did a bunch of clones that were not treated with DNA. And so they want you to answer the question, do you think all of these clones took up DNA or not? I'd be interested in your answer to that. All right, we're going to stop there.